p.m. Central Time. So 2 hours and 15 minutes away from the release of the Dragon spacecraft. That will come close to wrapping up this 23-day mission to the International Space Station. The deorbit burn will be at 10:42 a.m. Central Time today, with splashdown at 11:34 a.m. Central Time. Now, today's events were due to take place yesterday, but at the end of last week on Friday, SpaceX took a look at the weather there at the landing site. The sea states were pretty severe and did not allow for either splashdown to take place as planned yesterday, or the boats that will be taking part in today's rescue operations to leave harbor. But the weather has cooperated. Those boats are on station and are ready to support today's activities. The good news is that if splashdown would have taken place yesterday, it was going to be some 400 miles off the coast of Baja California, quite a ways out there and a little bit further than is typically desired for these missions. But due to the fact that we delayed by a day, and Dragon will be coming home later on this morning, the splashdown zone is much closer to the coast, about 240-something miles off the coast of Baja California, which means, of course, all the science that is coming back will get back to the harbor quite a bit faster than would have taken place if yesterday would have been the coming home day for Dragon. There is two different types of cargo involved with this flight in terms of being returned to NASA. There's some early return science, most of it the cold samples and the glacier, which is a freezer that's inside Dragon. All of that will be turned over to NASA actually at the harbor itself. Those samples will be flown back to Houston for quite a rapid turnaround for those experiment samples. The rest of the cargo will stay inside Dragon and will come back to SpaceX's McGregor, Texas facility for a normal turnaround time to NASA. Most of that is equipment and apparatus that is no longer needed on board the International Space Station, and that will come home in a matter of days. These two vehicles passing over Morocco and Algeria, and continuing a northwest to southeast pass over Africa. As we continue to watch these two vehicles flying over parts of Africa, we talked earlier about the different kinds of science that was involved in this mission, the kind that flew up to the station and is coming back home. There's quite a bit that had already been on board the space station and will come home at the conclusion of this mission this morning. And there's a lot of science that was delivered on this mission that will stay on board the station. So quite a bit of comings and goings in terms of science experiments. But in terms of the stuff that's being delivered to the station that will stay on board and come home at a later time, there's an experiment out of France called Energy. It takes a look at the energy balance in crew members following long-term space flight. A lot of that has to do with diet and exercise. We talked about the burning and suppression of solids experiment, that flame experiment that we have featured here on NASA television quite a bit. There are some of these nanoracks experiments that come out of high schools and college classes. There's one out of Fremont Christian High School that takes a look at robots and how different types of robotic mechanisms and mechanical devices can be controlled up in space, and whether it's feasible to use these to complete tasks controlled either by crew members or here on Earth. There's a seedling growth study that takes a look at how plants grow in space. Quite a number of these investigations looking at how plants behave in space. As you can imagine, it is quite a bit different than here on Earth. Not only does this teach us fundamental ideas about how plants behave, but it's probably a good idea if you're going to go to Mars one of these days to grow your own food instead of having to take it with you. So astronauts in the future will have to become somewhat familiar with their farming skills whenever it comes time to pull off those missions. So learning how these seeds and these plants behave in space is incredibly important. There's an advanced colloids experiment that comes out of New York University and also Procter & Gamble and also Harvard. It is designed to determine the effect of particle sizes and different types of fluids up in space, different types of colloids. There's an experiment out of the University of California, San Diego called the Flex 2. This looks at flame extinguishment experiment. That is what its technical name is. It is another one of these fiery experiments. It takes a look at how exactly you would put out something like that up in space. Valley Christian High School in San Jose, California has a couple of experiments as well that are flying in these nanoracks. One of them is called the electromagnetic effects on ferrofluid. It's a very complicated name for an experiment that takes a look at magnetic fields on different types of fluids. Valley Christian also has an electroplating experiment that was delivered that studies the effects of spaceflight on microplating, which has hopefully some benefits here on Earth. And then there is a ton of experiments that are coming back today. As we mentioned, there's 2,668 pounds of supplies that are returning to Earth. There's quite a bit of experiment from the space station itself, but a lot of this mission involves science that is coming back home. Some of this has been up on board the space station for a number of months. But there's an experiment out of the University of Waterloo in Ontario, Canada, called Vascular, that studies the impact of long-duration spaceflight on the blood vessels of astronauts. The longer we go on board the International Space Station and these crews that spend up to 6 months up there, we're learning more and more about how the human body reacts to being up in space, which of course is going to be incredibly important as we look to longer journeys. Our body's quite a complicated machine, and we need to understand it quite a bit more if we're ever going to make those flights. This experiment, this vascular experiment, notes that spaceflight actually accelerates the aging process, and people need to understand this to determine the need for specific countermeasures. How do you overcome it? So they've collected data before, during, and will collect data after spaceflight on the crews to assess the inflammation of the artery walls and changes in blood vessel properties and cardiovascular fitness, and come up with ways to combat that as we take a look at a live view inside the SpaceX Mission Control Center. That team there monitoring the progress of their vehicle as it still is attached to the station's arm and getting ready for release coming up a little more than 2 hours from now. The robotics officer here inside Mission Control has again confirmed to Scott Stover, the flight director, that the arm, the station's 58-foot-long robotic arm, is in motion once again. This is about a 17-minute maneuver that will move Dragon quite a bit away from the International Space Station, all things leading up to release about 2 hours from now. The release point is actually about 15 meters away from the International Space Station. And that is when the crew will take over momentarily to pull the trigger there from the robotics workstation and release Dragon and allow it to fly freely. A good look at the International Space Station there. That is the Columbus Laboratory, the European Space Agency's laboratory there on the far left. There in the middle is the Harmony node. That is where the station's arm is currently mounted and attached to the SpaceX Dragon spacecraft. Just out of view is the Japanese Kibo laboratory. It is directly across from Columbus.